What is up, geometry students? Coach Mester coming at you. We are going to do some more practice on scaling, real world situations. We need our calculator just to help us if we want. Most of the questions probably don't need a calculator for, but these two pentagons, we're told, or we can see that they're the same angles in the pentagons. We can see that these pentagons are similar to each other. So same shape, different size. We want to find some corresponding side lengths that we could use to understand scale factor from one to the other. Or we could compare side lengths within one of our objects to understand the comparison for the others. So we have A, B, C, D, E. BC is 4, CD is 5, AE is 3. And I can see RSTUV, that ST is going to correspond with BC. That will provide me a scale factor. 18 divided by 4 shows me that this pentagon is 4.5 times the size of the original pentagon. So that would be one way to approach this, is to just understand that AE, which is 3, times 4.5 will give us our value of RV, which is X. So 3 times 4.5 is 13.5. And then I can see that 5 times 4.5 will be, that is CD. CD is 5, will correspond to TU. So 5 times 4.5, which is 22.5, equals Y plus 2. So 22.5 equals Y plus 2, Y equals 20.5. Okay, now there's other ways to do this. We could have looked at the relationship between BC to DE, and we could have said that 4 to 5, that ratio, 5 to 4, 5 divided by 4 says that CD is 1.25 times the size of BC, which means you could have done, and this is just an example, 18 ST times 1.25, which is 22.5, to get Y plus 2 TU. And you would have gotten the same answer, just a different way. Be ready to either go from one object to the other, or to look within your objects to see the relationships of the side lengths. Number 2, JKL is similar to TUV with a scale factor of 3/4. Okay, so that just means you take JKL, which will be the bigger triangle, multiply by 3/4, and you'll get TUV. We are told what TUV is. TUV is 4 is TU, 6 is UV, and 8 will be VT or TV. Well, if you're going to multiply by 3/4 to get from the bigger triangle to the smaller triangle, and this is tricky, you're going to divide by 3/4 to get from the smaller triangle to the bigger triangle. Dividing by 3/4 is the same as multiplying by 4/3. I should be multiplying my side lengths by 3/4. This is my understanding of how this question is written. I can see you reading this question a little bit differently and coming up with like a different idea of like actually JKL. I read JKL as the smaller one, but I don't know. Like it's a little bit. I don't under. It's a little bit trickily worded. I don't love this question honestly. JKL is similar to TUV with a scale factor of 3/4. Maybe 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 JKL is the smaller one. Yeah, I'm gonna change my mind here. JKL is similar to TUV with a scale factor of 3/4. So maybe JKL is the smaller one. We'll make sure it's worded correctly. Usually we don't give you the scale factor, you determine it yourself. But all we're going to do is either, I don't know, depending on which one is the right one, take the numbers 4, 6, and 8 and multiply by 3/4. Oops. 6 times 3 divided by 4, 8 times 3 divided by 4. So I got 3, 4.5, and 6. Cool. Question number 3, we have these two parallel lengths, AB and DE. We are connecting AE and BD to create two similar triangles. Okay, we can see that the intersection's at C. So we have the triangle DCE, which is going to correspond with the triangle BCA. So this length DC of 6 will correspond with the length CB of 4. This is going to provide my scale factor that ABC is less than DCE. So 6 divided by 4, which is 1.5, will tell me kind of the scale factor. So that means this AC length of x plus 7 times the 1.5 will equal the CE length of 12 minus x. So I have 1.5x plus 7 times 1.5, which is 10.5. That equals 12 minus x. I'll solve this by adding x to both sides, subtracting 10.5 from 12 to get 1.5. I get 2.5x equals 1.5. I'll divide both sides by 2.5 to get 0.6. Cool. All right, number 4 is very much a similar question to what we have practiced on day 1. We have this smaller triangle ABE inside this bigger triangle AED. We can see that the smaller triangle AEB has a length of 6.25 and 10. And then the length of the bigger triangle ADC will be a length of x plus 2 plus 10. That would be AC, which would be x plus 12. And then the length of AD is x minus 1 plus 6.25. Well, that'll be x plus 5.25. Now, this is a very good question because you have to look at the relationships of the side lengths. You cannot say this triangle is this many times bigger than this triangle. So I am going to say that the longer side length of my triangle is 10 divided by 6.25, which is 1.6 times the length of my smaller side, which means this x plus 5.25 times 1.6 will equal the x plus 12. So x plus 5.25 times 1.6 will equal x plus 12. I really am setting up proportions and solving. If you like to set up proportions and then cross multiply and divide, that's fine. But I'm just kind of doing one step by understanding relationships. So I don't make a mistake when I'm setting things up. Like everything should make sense visually to do these problems. I'm going to subtract x to get 0.6x. I'm going to subtract 8.4 to get 3.6. I'm going to divide by 0.6 and I'll get 6. 3.6 divided by 0.6 is 6. Cool. Question number 5, kind of the same thing. We have triangles ABE and triangle CDE. They're going to be similar to each other. We can see they're same shape, different sizes. We can see that we have this length of AB, which is 2, and this length of CD, which is 5, which is showing me that this smaller triangle times 2.5. How did I get 2.5? I did 5 divided by 2 to find the scale factor. Will give me the big triangle. So that means this x minus 1 times 2.5 will give me x plus 5. So once my cursor comes back, I'll do that. 2.5 times x minus 1 will equal x plus 5. I'll get 2.5x minus 2.5 equals x plus 5. I'll subtract an x to get 1.5x equals 7.5. I'll divide 7.5 by 1.5 to get 5. Cool. This is similar to what we did in class, finding a length of a tower based on a proportional relationship, similar triangles. Only instead of a mirror, we're using shadows. So we got Alex, who is 6 feet tall, who creates a shadow of 9 feet, is standing next to the UT tower, whose shadow is 320 feet. How tall is the tower? Well, we can just see really quickly that the UT tower's triangle created will be 320 divided by 9 times the size. That's 35.555555556 or 329ths. I mean, I'm just going to leave it as 329ths. Oops. So I'm going to be 6 times 320 over 9. And I get 374 over 9, which is 640 over 3. Sorry, I didn't put a times, which is 213.333333. So 213 and a third feet, or 640 thirds feet. Cool. 2 more questions. Another shadow question. Only thing that is different is that we have this idea that we're using paces, but paces are approximately this many feet. We could see we got my guy Thales. He is using a staff that is 2 paces tall. His shadow is 3 paces. We could see that from the middle of the pyramid all the way to the tip of the shadow is 125 plus 114 paces. So that's 239 paces total. We can see the relative size that the pyramid will be 239 divided by 3 times the size. It's not a nice number, so I'll just leave it as 239 divided by 3. Which means I'm going to take these 2 paces of height and multiply it by 239 and divide by 3. So I'm just going to take the 2 and multiply by that. And I get 159 and a third, or 478 thirds paces. But I need to turn that into feet. I'm going to multiply this by 3. Well, guess what? Multiply a third by 3, and you just get 1, or 478 thirds paces times 3 will give me 478 feet. And now this is what we did in class using a mirror. We got the idea of a guy who's 1.2 meters tall, looks at a mirror, sees the reflection, hits the top of a very, very large tower. He then measured off the distance from himself to the mirror, and then the distance from the mirror to the base of the tower. We can see through the measurement of his distance to the mirror and the distance of the building to the mirror, the scale factor. We took a distance of 0.4 meters and turn it to 87.6 meters. So I'm going to divide 87.6 by 0.4 to figure out that the tower's triangle is 219 times the size of the dude's triangle, which means I'm going to take this 1.92 and multiply it by the 219. And I get 420.48. And that, my friends, is the homework. All right. Good stuff. Scaling. See you out there. Next class, we're talking about perimeters and areas. What happens to them when you scale. All right. Peace.